Wouldn't it be cool to have a way to make a network learn a representation able to improve semantic segmentation without using any annotated data? I'm Lucas and I'm here to present our proposed self-supervised pre-training for LiDAR data, which relies only on the point cloud structure to learn a representation via segments discrimination. Semantic scene understanding is crucial for autonomous driving. For LiDAR data, recent works use learning-based methods to train a network to extract this information. The challenge for learning-based methods is that many labeled data is necessary to train the models, and especially for LiDAR, the data annotation process is expensive and demands a lot of time. Also, the data collected from different LiDAR sensors inherit sensor-specific characteristics, making the model generalization challenging. The question is, how can we support it in a self-supervised way? In this work, we propose using contrastive learning for self-supervised pre-training on autonomous driving LiDAR data. Our method exploits the LiDAR point cloud's properties to partition a point cloud into segments by removing the ground plane and clustering the remaining points, achieving a coarse segmentation of the objects in the scene. Then, we apply a series of augmentations over the point cloud, generating a pair of augmented views. We compute pointwise features for both augmented point clouds using an encoder-decoder backbone in a Siamese network scheme. The segments points are mapped to the augmented point clouds, from where we list each augmented segment and its pointwise features. We pass the segments over a dropout and a global max pooling layer to compute only one feature vector per segment, and finally we pass the segment's feature vector over a linear projection head and compute the contrastive loss segment-wise. After pre-training with our method, we can fine-tune the backbone to different downstream tasks. In our experiments, we pre-train the network using the semantic kitty dataset without the labels and later fine-tuned to semantic segmentation, and we show that our method boosts the network performance, especially on the lowest label regimes. With only 0.1% of labels, our pre-trained network improved the network performance by around 10% when compared to the network without pre-training. Regarding generalization, we use the network pre-trained on semantic kitty to fine-tune to a different semantic segmentation dataset, which uses a different LiDAR and a different sensor setup. We compare our self-supervised pre-training method with the semantic segmentation supervised pre-training. And in this experiment, our proposed method achieves a better generalization, performing better than the pre-training with the labels, being consistently better when fine-tuning with different labels percentage. In this video, we can compare the ground truth labels with the network fine-tuned with only 0.1% of labels after returning with our method. And in the video, we can see that the overall structure of the scene can be interpreted by the network, and also the fine-grained structures like cars, poles, and traffic signs can be distinguished in the point cloud even when training with only a small portion of the labels. In summary, we propose in this paper a self-supervised representation learning method for autonomous driving LiDAR data. Our method exploits the LiDAR data structure to extract coarse object segments in the point cloud and apply the contrastive loss segment-wise. Our results show that our method improves the network performance, especially when there is few annotated data available, and our method achieves a better generalization, performing even better than the supervised pre-training when fine-tuning to a different dataset. If you find it interesting, our code is publicly available in this repository, and we invite you to check it out to reproduce these results or try new stuff. Thanks!